So anyway, our agenda today, like I already said, we're going to talk about what Splunk is, all right? Give you an idea, the overview of what Splunk is, and then we're going to talk about how to build apps that are available using Splunk as a platform for big data. So we'll look at that. So the name Splunk came from the term spelunking. So spelunking means going and exploring caves, right? The name Splunk is a play on spelunking, so we use Splunk to explore machine data. And this little quote right here, this is actually Splunk's mission statement. And the mission statement of Splunk is to make machine data accessible, usable, and valuable to everyone. And how do we do that? How do we deliver on that mission statement? So the way we deliver on that mission statement is the first thing you have to understand is what is machine data, because we're making machine data usable, valuable, and accessible to everyone. So machine data is basically anything that produces data. Machine data by nature is unstructured. That means you don't know the way the data looks like beforehand. It has no set rules. It's just, it starts with a timestamp, and it can be anything after that in the world. So all these things that are out there in the world, they're producing machine data. So this slide right here just shows you all types of things that are producing machine data. And we normally think of machine data as IT data. So you have things from Windows, you have things from appliances, you have applications producing log files. All this type of stuff is producing machine data. We actually go into non-IT things like this. I've done big oil and gas where drill bits are producing machine data. All these SCADA devices are producing machine data. You can use Splunk for any kind of machine data. And when we talk about unstructured, this is very important that there's no upfront schema. So if you're a database guy, like I came from database backend before I joined Splunk, and I always thought, all right, I'm going to create this database, I'm going to create this relational database. Let me think of what I need to put in my database. I'm going to create this schema, which is just a definition of here's all the tables that are in my database. Here's all the fields that go on that table. Here's how they all relate with primary foreign key relationship, making it sure everything's normalized, very, very rigid and structured. The problem with that is for machine data, there is no upfront schema. You don't know what it looks like, and some vendor can change it on the fly and say, we have this syslog, we're going to add something to it, and if you don't already have that accounted for beforehand, then you don't have that information. So basically, when you're creating a schema, you have to think, what questions am I going to ask of this data before I ever get data in? So I'm creating a schema, so I'm going to ask this question, so I need to make sure I collect that information, and this is how it relates. With Splunk, you don't need any of that. There's no structure. Splunk doesn't even know what the data looks like before it gets there. You can just send data into Splunk, and we're good. And so that means there's no custom connectors for trying to massage data, go get data from here, turn it into this format that I can then put in my database. No, none of that. And then there's no relational database management system, which means Splunk is just software. You just install Splunk. There's no, I don't need a SQL server. I don't need HA. I don't need all these load balancing appliances. You just need software. And there's no need to do all this massaging and filtering and forwarding and all that kind of stuff. So there's really two parts to Splunk. So we're going to talk about what Splunk is and then talk about Splunk apps. But when I talk about what Splunk is, there's really two things that we're talking about with Splunk. Because Splunk is a platform for machine data. So what that means is, first thing, we got to get data into the platform. And then we're going to do data analytics on top of that data. So the first thing I want to talk about is how we get data into the platform. And so we have, I got to go over here to the computer to do this. What I want to talk about here is when you install Splunk and you say, all right, I install Splunk and it says go to this URL when you're done. So it says, all right, go to this URL and this is what you get. You get this search bar and all this stuff that's going on. Now I have data in, and so you have to get this data in, and we're going to talk about this in just a minute. But you really don't, this gives you a search where you can go search for things in your environment, which is cool. But before you can search for things in your environment or do pretty apps or visualizations, you have to get data into the platform. And there's several different ways to do that. So a lot of times in a virtualization environment, your infrastructure is producing data. So you have switches that are doing syslog messages. You have virtualization layers like Hyper-V, VMware, XenServer, whatever, they're producing data. If you're doing like, we're going to talk about XenApp today on our example. So you have XenApp components producing data, you have firewalls producing data, all these things are producing data. And if we can get them in one place, such as Splunk, then we can do a lot of correlations. We get a really big picture overview and drill down very fine-grained as well. So our first step is to get data in. So the way you get data into Splunk, it depends on the type of data, or the way the data is produced. Really, it's not the type of data, the way the data is produced. So I mentioned like a firewall and switches and things like that, they have syslog. And so you can go in and configure, say, syslog, deliver your syslog messages straight to Splunk, and Splunk can just say, all right, I'm here as a receiver, I can receive that syslog, and I'll put it into my Splunk instance here. It's important to note that Splunk is not a database, so I always say Splunk, I always wanted to say from old school Splunk database because I came from database background, but it's not a database, so I call it Splunk instance. So you can say, all right, syslog, go directly to Splunk, no problem. Another thing you can do is if something is producing a log file on disk already, so if an application is producing a log file, an operating system is producing a log file, something's producing a log file that's there, you can just tell Splunk to monitor that log file. Anything new that comes in, just feed that straight into your Splunk instance as well. Sometimes things are not persistent on disk. So if you have something like, for instance, we're talking about XenApp here. If you have a XenApp environment, there are things such as your farm configuration, your published applications. They technically exist on disk in a data store, but as you know, a data store is not readable. It's a blob, binary large object, so you can't go read it directly, but you can get to it via your APIs, via PowerShell or MFCOM. So Splunk has the option, says, all right, run this script, and whatever the output of that script is, just feed that into Splunk as if it was a log file, but it's not really ever exist on disk anywhere. Same thing with sessions. Those things are transient, so you have sessions that come and go. You can have those things, we have the API that can go grab that information and just feed that directly in Splunk. So now you have that persistent on disk in your Splunk instance. So we have a way to get all this data in.
Yeah, it's important that, I want to mention this, it's important that what he just said, we kind of glossed over it. We don't write anything to disk, right? At least on the agent. So one of the biggest failures that you see when you do VDA or Xen desktop monitoring is that typically what happens is the agent will write like a file to disk on that agent, and then every once in a while it will report that back to the backend database. The way that, at least the way that we approached it with Splunk and the way that Uber Agent does it as well, is we do the data collection. At data collection time, we just update that stuff directly to Splunk. We don't store anything to disk. So we have a very minimal to no disk IOP impact on the VDA.
Yep, that's a very important point, because that segues right into the next point that I wanted to make, because people always ask when they come talk to us, it's like, all right, well, do you have an agent? Are you an agent-based solution? And the answer is kinda, maybe, depends. So like I said, for devices that are producing data like syslog and like, there's no agent there. Just go straight to Splunk, no problem. But when we're talking about like a Xen desktop, Xen app environment where you need to go collect stuff from these computers, we do something called a universal forwarder. So what that thing does is it collects information locally on the device and sends it over to Splunk. And so you can think of it as an agent, but because the next thing people say is, what's the overhead of your agent? And the question again is, if you're in a XenApp world, you're used to this, it depends. Because basically what we're doing with that thing, you install it, it does nothing by default. You install this universal forwarder on a Windows box or whatever, it doesn't do anything. You have to tell it what to do. And so we tell it, go collect this log file, run this script, several different things, collect these performance monitors, and send it over to Splunk. Again, like Brandon said, we don't write it to disk. It just goes over the wire to Splunk. We write to disk at Splunk. That way we keep the performance impact very low. And so when people say, what's the overhead of your agent? It says, well, it depends on what you tell the agent to do. For what we're telling the agent to do, which is totally configurable, you don't have to tell the agent to do what we're telling it to do. But we're saying, hey, go get these Windows event logs, which they're already on disk. We didn't produce that data. We're just saying, go get new event logs, send it over to your Splunk instance across the wire. Where you start getting into overhead is we use a lot of PowerShell scripts or MFCOM scripts depending on platform. And so that script will run to go grab that information and send it across the wire. So whatever would go to standard out, so meaning your screen, if you're writing a script, is what ends up in the Splunk index and never gets written to disk. It just goes straight across the wire to Splunk. And so that script has a little bit of overhead, but then you say, all right, well, have you written scripts yourself and run them? Then you know the impact of those scripts on your environment. That's the same thing as Splunk. So we have these universal forwarders that are collecting this data, sending it over to Splunk, and then we can do a lot of analytics once we get it into Splunk. And then you can even do remote stuff, so you don't have to use a universal forwarder everywhere. If you can just reach out and grab something remotely, you can do that. So you lots of options, very, very flexible. So I'll show you some of the scripts that we're doing in Splunk. So what I have here is a virtual machine that is a XenApp 6.5 server, and I have...
Can everyone see that fine? Yeah? Guys in the very back?
Can you see it? Good. Awesome.
No, he said I can't.
No, well, the guy in the very back give me a thumbs up.
Oh, okay.
Yeah.
He doesn't have glasses. The other guy's got glasses.
So what this is doing, so this is just a PowerShell repository. You can see here from the folder path, I'm in Program Files, Splunk Universal Forwarder, and this is where you put in your configurations where we tell Splunk what to do. And part of the XenApp, we're saying go grab some. You can see it now.
Is it better?
We're telling Splunk to go grab some event logs and go grab some performance monitor things. But like I said, things that don't exist on disk, we have to have some other way to get that information. So what we're doing is we're running several PowerShell scripts that Brandon actually wrote because he's a PowerShell zealot. So we're running all these PowerShell scripts.
If they work good, I wrote them. If I didn't, if they don't work good, I didn't. I had nothing to do with it.
So these scripts, what they do is they go against the Citrix API to grab stuff like, if you want to get a server, you can go ahead and just do the get XA server is fine. Oh, I mean, well, not the PowerShell actually, but not the commandlet, but the script that you wrote.
Oh.
So that was the commandlet, by the way. This is what, if you just run the PowerShell commandlet from Citrix, that's what you get. And so Brandon if it's good, Brandon put this together. So this is basically what we're doing here. So this says get XA server. Like I said, machine data starts out with a timestamp right there, and then stuff after it, right? We don't care what that stuff is after it. It doesn't have to be in any kind of format, but machine data by definition is time series.
For you people on the back, it's just a bunch of letters.
Yeah. We got a question.
Yes, sir.
So how is that data fed into Splunk? Is there a PowerShell API for Splunk?
No. So what he was trying to explain. So the universal forwarder, and it doesn't matter. It doesn't have to be PowerShell. Whatever language you want to write in. It can be anywhere from C to Ruby. It doesn't matter what language, whatever you're comfortable with. What will happen is the universal forwarder will launch that script. Whatever that script writes to standard out will get shipped to Splunk.
Yep. And but that's a good point that you just made. This is PowerShell. The API is PowerShell, so it's easy to do PowerShell. You could write this in VB script. You could write it. You could write
whatever language you want.
Whatever.
Doesn't
matter. Whatever the operating
system. That's why when people ask me what can Splunk do, I'm like,
whatever.
Pretty
you want.
much anything, but it's within reason. But
yeah. So if you write a script, whatever ends up on the screen, like I'm about to show you, whatever ends up on the screen here is what ends up in Splunk. And so it's important. This does not get written to disk. It just goes across the wire into Splunk, and I'll show you what that looks like in a minute. So, we just see here that our little script here ran the PowerShell commandlet and then just put it out in a long format here instead of doing that.
And I can tell you, so the reason why, basically this is key value pairs. So when you put the data in Splunk, and he'll get into more details into this, I think, in a little bit. But when you put data into Splunk, you can educate Splunk on how that data, like what means what. What does that data look like? If you use key value pairs, you just kind of get it for free. So when we wrote these scripts, instead of writing a whole bunch of configs for Splunk to know what the data look like, if you do key value pairs, Splunk just knows that those are related fields and values. So it just kind of does the right thing.
Yep. All right. So you see, I just wanted to show this, how we're collecting the data. So when I go into this part over here, this is the Splunk web interface, that you'll see that it wasn't just magic that this data showed up. We're telling it how to get the data in. So like I said, there's two parts. One, you got to get the data into Splunk, and the second part is doing your data analytics. So now we have data coming into Splunk, and now we want to do some analytics. So in Splunk, all your data is stored in what's called an index. You can think of it as a database if that helps, but it's just a logical separation of data. So we store all the XenApp data in an index called XenApp. Shocking. And so basically what I'm telling Splunk to do now is go look at this index, which is just it's actually just a folder on the disk, and give me all the information you have in that folder. So I mean, it's more than that, but that's what we're doing here. So I'm saying, hey, Splunk, go give me all the information that you know about XenApp, and here's what we have. And whenever we tell that universal forwarder to go run a PowerShell script, we're also telling it to tag it with the type of data that it is. So it's called a source type. There's 3 pieces of information that Splunk just tags with all data, and that's called the host, the source, and the source type. The host is where the data came from. The source is actually what produced the data, and the source type we get to define. So we're saying,
White.
yeah, there. Thank you, Vanna. You're really good at that. And so for that one that we just did, that server one, this is source type over here, server. And so when I click on that, you'll see that all that PowerShell commandlet, date and time stamp stuff after it, that's the output from that PowerShell script that ran. So that's how we're getting data in. And that's not the only way. If there's a log file, you can just point at a log file. But if you don't have something that already exists, it just shows you how extensible Splunk is. You could even have Splunk Go query REST API. If you had some kind of system that exposed endpoint via REST, not a problem. You can do that as well. PowerShell, any kind of scripting language, it doesn't matter. Whatever your operating system understands, Splunk will run that, pop it in, we're good to go. So this gives you an idea of what we're doing. But probably by now, you're still saying, so what? And it's like, we got some script output into this nice, pretty web front end. So, so what? Well, this is so what. Like I said, there's 2 parts. There's getting data in, which we just covered. Now, there's data analytics. So a good kind of data analytics that you might want to do is say, index equals XenApp, and maybe I want to know what my sessions look like over the past few hours. So I go to 24 hours because, like I said, all machine data is time seriesed. So we can always say how far we want to go back. If we want to do some custom time, if you want to go, you can do relative. I can go distinct time if I want to go define a time, whatever. Everything's time series. Also interesting enough is you can do real time. So you can have real time. As data comes in, you can see it update in real time. But I'm just going to say for the past 24 hours, I'm really interested in my session data. So I'll go over here to my source type is a session right there. And so now I'm telling Splunk, give me all the session information that's in XenApp. And maybe I want to do, again, this is so what.
Did you explain stuff over here real quick? Or did you
yeah, let's talk about that. All right, so this is important. So what Splunk is also doing is every kind of like logical separation here, you see there's a 1, 2, 3. Every one of these things is called an event. So it's the output from a script or a single line in a log file or something like that. And so what's happening is Splunk is looking at all of this stuff in real time. Like as we're typing stuff over here, Splunk is examining this information. And over here on the left-hand side, it's giving us some things that it's saying, here's are some interesting fields. And all of this is done at search time. And what makes a field interesting is, Brandon already said, there's these key value pairs like color depth equals that. So there's a field called color depth over here. And what makes a field interesting is Splunk sees that in more than 50% of the events here. So it says, I see this coming up a lot. This is probably interesting to you. And so you can go over here and click on something. So let me find something that has more. Here's like client IPv4 address. If I want to go get some more information, here's the top values. I could create charts out of this right here if I wanted to. So actually, I guess I could do that. So I'll do the top values over time. I just click on that, and Splunk will create a pretty chart for me of the top IP addresses over time. So it just does that automatically for us.
So you didn't even have to know anything about Splunk except for clicking. Right?
Yeah, I'm just clicking. I haven't typed anything other than index equals Zenat, and then clicked on the source type and all that. So it gives you the ability to do all this, but that's we're getting into data analytics stuff, but it's really cool that Splunk is giving you all of these interesting fields in real time. Okay.
Yes, sir.
Is it interesting because the key is in the data in 50% of it?
So it doesn't have the key. The key in the key value pair doesn't have to be in the data. You can educate Splunk. So Splunk kind of does some of its own magic to figure out that there's a relationship here, right? Username equals Brandon, right? So it kind of is like, oh, well, there's this field called username, and it seems to be this value called Brandon. I think they're related, right? Splunk does it out of the box kind of magically. If that key would have been uname space Brandon, right, and there wasn't an equals, you can tell Splunk, hey, use this regular expression. When you see uname, that equals username, and when you see the value, like when you see this part of the regular expression, that's the value. If you do that, it will still work. Like it doesn't have to be in this format for that to work. These are basically, when Splunk does a search, it does the field extract, what we call field extraction. It does that at search time. What it extracts, it puts over here. When it sees a field more than 50% of the data, that's when it puts it on the interesting field list.
So just seeing the field is interesting, not the content.
It has nothing to do with the value. It's how often I see the field.
All right. And so, yeah, Brandon mentioned that when we're writing the scripts, it's very easy for Splunk to see this equals that, this equals that. That's the key value pairs. So if you write a script, you might as well make it easy on yourself and do it that way. A lot of times syslog comes in, it's just a timestamp and a bunch of stuff. There's no key value. So a lot of the standard syslog stuff like web and a lot of the Cisco appliances and things like that will give you the, it's basically a file that tells that when you see this data, this is what it means. But you can create your own as well, which we've had to do that.
Splunk actually ships with, I want to say 50 plus known data types. And a good example of this would be like Apache logs. So somebody at Splunk went through standard Apache log and kind of did the work for you. You could change it, you can modify it, but I think there's like 50 some types of data that Splunk just natively kind of knows out of the box. If it's not one of those, you kind of have to educate Splunk on how to do it. And that's actually not hard. It's a little bit of a learning curve if you don't know regular expressions, but it's not that difficult.
Yeah, good question. All right, so back to this stuff we're about to do, some data analytics. So what I'm about to do now, all I've done so far is narrowed my data set that I'm looking at. Now I want to do something interesting with it. So this is where what comes in, we call the Splunk Search language. And it's just like basically any kind of command line language where you take one thing, you pipe it to another thing, and you pipe it to another thing. We give you all these search commands that allow you to do all this data analytics. So I'm going to take all my data that I've done here, and I'm going to pipe it to another command because I'm interested in something about this data. So I'm looking at session data. It would probably be a good idea if I wanted to see, within the session data, there's a field called browser name. In Citrix terms, that means the publish application name that you launched the session with. And so maybe I want to look at all the browser names out there that people are using. So we're in the past 24 hours. I do this pipe command, and you'll also see it's kind of an IntelliSense thing that pops up here as I start typing these commands. It'll say, here's, once I start typing a command, it'll say, here's how that command is formatted, and here's some useful information about it.
Yeah, so that top section are searches that you've done before. That it says this is looking similar to, so if you do a search and you want to go back and do that search because you changed something or you're looking at a different, you can just click one of those. And then at the bottom it says the common next command. So it's like saying, here's some things that people would put next, right? So it kind of gives you, like as you're learning Splunk, actually the chair drop we have here is this Trifold. And this Trifold is actually spectacular. It's one of my favorite Trifolds ever made. And I loved it before I was even at Splunk. It'll give you some ideas of what those search commands are. But we try to educate you on the UI as well. So as you're going, you can click, and if you do the stats, it'll give you kind of help text on that side to let you know this is kind of what you would do with that command.
Yep. So stats is actually the one I was going to use. So stats just short for statistics. I want to do some statistics on this data, and you see here's some. There's the command history, but also on the right-hand side, it gives you the help and more information and examples on how to use the command. So you're not totally on your own. As you start typing this stuff, you can get some ideas. And so I'm actually going to use one of I'm going to do a distinct count, which means I want to see the distinct count of my browser names. So DC is just short for distinct count. I could type out distinct count if I wanted to. And I could just do a stats distinct count, browser name by date. That's the one that's sitting there, right there. So actually, well, it's only going to be today, but in 24 hours, so that's not very good. I'll just do a stats distinct count, or by browser name. Actually, just a count, sorry.
Yes.
That would probably cause Splunk not to do what I wanted to do.
And it's case sensitive sometimes as well.
Yeah, the fields are case sensitive. So what I've told Splunk to do now is I'm in the 24-hour range, and I want to do some statistics. I want to count how many times it sees each browser name in that period of time. Now, this would represent how many times that particular application is launched within 24 hours. So that's what we have here. And so you can go through here and you can scroll through this tabular data, but if you really like visual stuff, you can turn this into a nice pretty pie chart. So I can just click on this little button here that says I want to create a chart. By default, it just has the last kind of chart formatting I did, which was a line. But if I wanted to do a pie chart, this gives me a nice visualization of, well, it's pretty uniform on the launching. Normally it's not that way, but it gives me an idea of what's my most used application visually. And so I can mouse over all these things and kind of get all, an idea of what's going on. It shows me the browser name and then how many times it's seen it, and the percentage of what that represents. And so that's really cool. We can do all this, but I don't want somebody to have to type this out every time, It would just be cool if I could give somebody a URL that had this chart on it. So what we do right here is this is when we start getting into what we call creating apps. So far we're just talking about Splunk as a platform for machine data. And so I really want to go create an app. And so I say I want to create a dashboard panel out of this chart. And what Splunk's going to do is it steps me through this wizard, and I'm just going to call it top apps. And then I click next. And then what's happening now is it's saying you can do an existing dashboard if I already had one, which I probably do, but I'm just going to do a new one called BriForum. So I'm going to create a dashboard called BriForum, and then click next. And then call it top apps right here, and click finish. And it's creating this dashboard panel for me that now I can give somebody this URL instead of making you go type all that stuff. And so Splunk is creating this dashboard for me. It's giving me these UI visualizations. And I can go edit this if I wanted to, edit this visualization. I have a lot of these things that are going on. If I want to change, put some axis titles on it. If I even wanted to change the type of chart, whatever, I could do all that. Save it out, we're good to go. Doing the same exercise, if I wanted to go do a new search, now you say I'm getting this search language down, and I'm going to do the same kind of source type, and maybe a stats count instead of by browser name, user name. I think it's user name, if I remember correctly. Yep. So I could get the most frequent users, or if I just wanted to, maybe I wanted to see how people are logging on over time, I can just do a time chart right here. Count. What should I do? Let's see. Count.
Session UUID, right? Would be the. You want to see unique sessions? I would do DC by session UUID.
Let's see, stats, DC by, what were you saying, the,
Session UUID. UID.
yeah, I'll just try ID, I don't know if that's one.
It's UID.
I had to go back over here, sorry. Sorry about this. Okay, so I don't, this goes back to the interesting fields. I don't remember the name of it. Was it session just UID?
Session UID.
Yeah, UID. Time chart, count by, hopefully that works. All right, so what this is going to do is give us a nice look at all the sessions that are going on in our environment, so we can see right here. And so if we wanted to have this chart be on our dashboard we just created, we could go through the same wizard. This time, instead of using, we can use an existing dashboard, the one that we just created. And then I'll just let it keep that. And then we go to our dashboard. So now we have two searches that were interesting to, whoever in our company. We have them on our dashboard. And then visually, we can say, I want to rearrange these. I want to have this over here beside it. Click Edit Off, and now we have all this dashboard that was created for us with very minimum effort involved. So now we're getting into, we have our data in, we've done some data analytics, and now we're on the cusp of what we call creating apps on top of Splunk. So Splunk is a data platform, big data platform. We're giving you the analytic tools. And so we don't want you to have to do all this stuff yourself. You can, obviously. And actually, once we start creating these apps, really what we're doing is just this over and over again. And an app itself sits on top of Splunk. And it's just this, a search and a visualization and some correlations and things like that. And the app itself is open source and free. You can actually go, if I wanted to look at the source of this, you can go look at the source of this application, not a problem. It's just a configuration file. So when we start talking about apps, is basically, I'll do the Zen app one. When we start talking about apps, basically all that is Splunk is there, it has the data in, we give you the configurations on how to get the data in, so the scripts and the different things to look at. You don't have to use any of the scripts, you don't have to look at the performance stuff if you don't want to. You can go configure what data you want to bring into Splunk, and then we give you the tools to make some sense out of that data for you out of the box. Again, you don't have to use this, but at least this does a lot of the use cases for you out of the box.
Or if you want to make your own, or you may want to make them specific to a specific, you want to use them targeted to a specific group. So you want to build your own apps. Splunk doesn't have to create apps for you. And I think the easiest way for me to understand what an app is it's just a bunch of searches and dashboards that you've created for somebody. And because we had nothing else to call it, we called it an app.
Yeah.
So you can create for your own group, like if you wanted to create a Splunk app for sales, like a sales utilization, Zen app utilization for sales. You can go and create a dashboard or an app for that, and then send that URL to the sales guys so that they're able to see what their URL or their Zen app usage is for their specific group. Or if you want to create different dashboards for different target audiences, like if you want to create one for IT and you want to create one for the executives and you want to create one for your sales and marketing guys, you can show each one of the groups of people what makes sense to them inside of your app. And the best person to make those decisions is not Splunk. The best person to make those decisions as to who wants to see what is you. So we offer these as what we call like examples, or you can use them as a product and you can just go download them and use them just as they are if you want. But if you want to go and change them and do your own thing, have at it. There's nothing kind of proprietary there. There's nothing we did here that you can't do yourself. There was a question.
So do you provide standard scripts along these apps, whether it's PowerShell or...
All right, so we'll take a little bit step back. So we're what we call practice managers. So I own data center at Splunk, and what that means is that the things inside of the data center outside of Microsoft, which is owned because it's a big enough slice of the pie that's owned by a different practice manager, and security is owned by a different practice manager. Everything outside of that is owned by my group, which is Jason, which owns virtualization, and then I have Hal Rottenberg, so some of you might know him. He does the infrastructure stuff. And then I kind of just manage the overall thing. And the reason why I kind of give you that breakdown is because what we're doing is we look at the specific verticals, Jason obviously virtualization, and he looks for places where data collection hasn't been done, or there's need for data collection. So we saw that with XenApp and XenDesktop. You guys can create dashboards. It's a little bit of there's a little bit of a learning curve, but once you get past that, that's really trivial part of the work. So the dashboards, not a big deal, really, long term. What's really a big deal is getting the data into Splunk. So we're investing a lot of our energy, and a lot of Jason's and Hal's and mine energy going forward is going to be exactly that. We're going to focus on helping you get the data in, and then let you deal. And the reason why we're doing that also is because in the next release of Splunk, the UI stuff is even easier than this, right? It's like really kind of widgety, click, drag, drop, field drop down stuff. You don't have to do any kind of search language at all, really. You can just click your way through it. So I don't want to invest a lot of energy on that. What I want to do is get the data into Splunk, because that's the hardest part, and getting the data knowledge. So getting the data into Splunk is part of the problem. The other thing is data knowledge, which is knowing what that data is and what's important in that data. Like just throwing a bunch of text at Splunk isn't valuable, right? It's a place to put it, and that's great, but it isn't valuable. What's valuable is the knowledge inside of that data, and saying that username is in here, this field is in there, or some statistical value inside of that data. So what we'll do is we'll add data knowledge and getting the data into Splunk, and then allow you guys to kind of build your dashboards on top of that. The way that we do that, we call those collectors. So you'll go in on Splunk base, and you'll see I think you have a TA for Zen Server. He has a TA. He's going to have one for Hyper-V.
Hyper-V.
So we're going to start doing that going forward. You're going to see a lot of stuff which isn't really an app, right? It's just a data collector. And then there may be some dashboards on Splunk base, but that's more of just kind of giving you an example of what you can do. So that's actually our plan going forward, is to focus on data collectors and data knowledge, and then and also working with partners. So people like ExtraHop and Nutanix. There was a couple of other vendors where because they haven't, it's like we can't know everything about every types of data. So we're going to a lot of customers or a lot of partners and like, hey, if you can just write this data collector and give us some knowledge about your app, we can get that data into Splunk, and then we can correlate it to stuff that you may not know about. So like the storage, and he knows the networking. If you both write your own things, we can put it in the Splunk, and then we can correlate the two so that everyone knows everything about both, right?
Right.
So that's our plan kind of going forward.
Yep.
Yes, sir.
What's the back end for Splunk?
There is no backend for Splunk.
Where do you put the data?
Zip files. Zip files. I mean, when people say, when we say there is no database, there is no database. They're flat files.
Yeah.
They're just compressed zip files.
Yeah. And so
The
Splunk,
magic sauce is the way that we deal with that in a really performant way, and we're able to get that data out fast in a map-reduced searchability thing. That's kind of that's like if there was magic sauce in Splunk, that's what we do. How the data stored is irrelevant. But it's not a database. There's no back end. When you install Splunk, you get it. It's just a file on a disk, which is kind of cool because as long as you can see, as long as you have a file system on the disk, you can store that Splunk index anywhere. It can be on tier 1 storage, it can be on tier 2 storage, it can be on tier 3 storage, and we have what we call buckets. So you can have hot store, cold store, and warm store. So you can actually tier your data. So if you want to keep 3 years of data or 5 years of data or keep the data indefinitely, you don't have to just put it all on tier 1 storage because you really want high performance for that real-time data. So you can do a lot of that stuff because it's just file system. And you can also put on, I'm going to mess this up, the clustered file system, ZFS. So there's a lot of stuff that you can do. And Isilon, I don't know if you know anything about EMC. Isilon, their group is kind of looking at that because they do similar things into where they can provide high speed. Atlantis. We're working with Atlantis because there's a lot of possibility of putting like your tier 1 storage or your hot bucket for Splunk on Atlantis. So you get like 30,000, 40,000 IOPS instead of 800 IOPS that you would get on a normal disk. So there's a lot of things you can do with that. It's probably way more than I need to say. But
well, I mean, also it's important that Splunk is software, and I guess I don't have my internet connection going here. I was trying to pull up the Splunk website. You just install it on, you have to have an operating system. Operating system, I'm running it here on my Mac. You can put it on Unix, you can put it on Windows. It installs on multiple platforms. And so once you install Splunk, that's where you get into what Brandon said, we store it on that operating system. And then I have some slides on architecture here. I don't think we're going to be able to get to them, but it's a very scalable architecture. So as you get into, it's like I have this one node and I'm getting into where I need more search horsepower. I can put in another Splunk server here, say there's your new Splunk server, there's no hardware load balancer, there's nothing more infrastructure needed. Then it starts load balancing between those two automatically. And then we have clients who are doing hundreds of terabytes of data every day coming into Splunk. They have like 50, 60 servers just for Splunk to be able to do all that. But it's still same executables that I'm running on my laptop are the exact same things that they're running in their huge data center.
I mean, think about
It's just
being able to
software.
search, 100 terabytes of data in real time, right? It sounds like craziness, but you can do that, right? The cool thing about Splunk is because it's map reduced, the more servers you throw at it, the faster it gets, right? So scale isn't a real big issue for us, which is a kind of opposite of most monitoring products, right? Most monitoring products, their biggest issue is when you start getting into customers that have hundreds of thousands of desktops, those monitoring tools just collapse, right? Because they can't handle, I mean, who wants a 100 terabyte SQL server, right? Trying to maintain monitoring data. First of all, who wants to spend, have an 8-node SQL cluster for monitoring data? It doesn't make a lot of sense. So in our case, it's, and we use commodity hardware, right? So when we say a Splunk indexer, we're not CPU intensive. Well, we have some CPU usage, and we're not memory intensive. So you can just get like a pizza box, like 8 cores. I think it's 8 cores, 8 gigs of RAM, and 800 IOPS is 100 gigabytes, not terabyte. That would be insane. 100 gigabytes. So if you just kind of multiply that out as you go, and it also has to do with the type of data you're pulling in and the searches you're doing, because the search head, which is kind of what you see here, that's what we call a search head. This isn't necessarily, doesn't have to be an index, or it can be, but they can be separate. So you can actually tier your infrastructure. I had a guy come up earlier and asked, well, if I have data centers in different areas of the country or in the world, can I have Splunk indexers in each one of those but have a searchable syntax? So the environment is very customizable, and it's actually not that hard to manage once you get it out there. If you do it right, that's the key, is make sure you do it right the first time. Yes, sir.
So I'm asking for my question, but
No, that's good.
I'm having trouble understanding how Splunk is able to understand that data, considering that it doesn't get into the ICA session itself. Is that also pulled from?
Yeah, so this ICA data right here, what that is a performance count. In this particular case, that's a performance counter. That could be an extra hop data feed. That could be a NetScaler data feed. Where the data comes from, again, doesn't really matter. In this particular case, it's a Windows Performance Monitor counter that says ICA session blah, blah, blah equals blah. And then we do some statistics on that value over time by a specific user value. Does that make sense?
Yes.
So that's how we do that. Okay. Unless there's any other more questions, we'll kind of let Jason go on.
No, this is good stuff. So, I mean, a lot of this is, we're talking about the data and how the data gets in, which were really great questions. And then what Brandon mentioned earlier, that our group, we get the data in, we help you get those data sources in. Then we don't leave you high and dry there. So we'll give you basically some dashboards that are use case driven. And so you say, here's some use cases that are common out in the field. Most of the people that download these apps, they use it as a starting place, right? They said, here's several use cases that apply to me. These things don't apply to me. I'll get rid of those. But then I'll look at how these apps were done, the searches that were done, and I'm going to add to it, because the apps themselves are open source and free. You can download those, look at how they're done, and say, that's almost what I want. Let me tweak it a little bit. But for instance, this use case that I was looking at now, and you saw the ICA session stuff over here. The use case here is for XenApp. And what this particular use case is like, somebody calls in and says, my session's slow, or my app is slow, And in a Splunk world, since, a lot of times you'll have this term called blame storming, where you'll have the Citrix team gets on and says, everything looks good here, call the storage guys, everything looks good here, call the virtualization guys, everything looks good here. Everybody's saying everything looks good.
It's not me, it's the network guy. It's not me, it's the storage guy.
Yeah, used to always be the storage guy. Now it's the network guy. And anyway.
Well, it used to be the network guy. Now it's the storage guy. Everyone blames storage at this
backwards.
point,
Yeah, storage.
which is why there's 20 storage startups every year now.
Yep. So anyway, what the idea on this use case for this dashboard? Somebody calls in. You can go any kind of time that you want to, and so we can, even if it's the weekend, we say, let me look over the weekend, see what was going on. We have all this data coming in from from your Splunk environment, all the different pieces of your infrastructure. And so what we're looking at here is we're just kind of scoring the data again. If you don't like the way this is done, don't like the icons, all changeable.
I'll give you an example. We actually had a customer, and we went into that customer. They were using a competitive product, and it was just not working, and they were having all kinds of problems. They had saw a demo of this product, this in-desktop thing. They went to the sales, they went through the whole thing. They had 250,000 desktops, so it's a large customer. And they bought the product because of this, and the first thing they did was threw everything out the window except for the data collectors, right? They're like, okay, we don't care, because they had very specific, like that, we don't care about this stuff, we want to do other dashboards. We like the data, we don't care about the dashboards, but the dashboards were useful for explaining use cases and showing you what the data can do. Sorry.
Yeah. Yeah, so in this particular use case, what we're doing here is there's, you'd think of a desktop virtualization layer, there's lots of pieces to it. So pieces of your stack, you have your networking, you have your storage, if it's virtualized, you have hypervisors, you have your load balancers, you have front-end SSL VPNs, whatever. All those things apply. So what we're doing here is we're basically starting with the Citrix data. You already saw the ICA session latency thing. So what we're doing here is we have this little drop down to see what that looked like. We're looking over 24 hours. We want to see what it looked like over 24 hours. We'll see it's high, but it's just, consistently high, which ICA can normally deal with that. If you see a lot of jitter, then that's probably a problem there. So we look farther down the stack. We look at the actual XenApp host this person was on. We see the processor time here is pretty high. So again, we can do the same thing, drop down, see what it looks like over the past 24 hours. And we see it's sustained over the past 24 hours really high. And a lot of times you'll just stop there. But what Splunk's doing here is it's looking to see if this is a virtual server. And it just happens to be a virtual server. And we go look at the hypervisor host that it's running on. This particular data set has nothing to do with XenApp other than, XenApp's not producing this data. This could be VMware, it could be Hyper-V. It happens to be XenServer in this particular case. But we can correlate this data together because it's all in Splunk. And so we can say, this applies to this user session because it's a virtual server. We could do our same drop-down list here, see the actual hypervisor is pegged out as well. So we can click on this link here. We're going into another Splunk app that gives us information about the virtual server or the hypervisor host that this VM is running on. And we see all the individual CPUs are all maxed out on this server. This little red guy right here is saying for every one physical CPU, you have 5.17 virtual CPUs assigned, which is a little bit high on the proximity there on the ratio. And all the things are maxed out. So at this point, we know we have a hypervisor problem. We probably need to do some migration to VMs, something like that. So again, this is just a use case. There's more information down here about Windows event logs, and if we want to look at the running processes on this thing as well. But this is just a use case driven scenario. You don't have to use this use case. A lot of people like this use case because we just mentioned storage. If we go do the same kind of exercise that we did a minute ago, we do our Bob's calling in. Before it was Dan. We have Bob calling in now. Kind of do our same exercise. Right at this point, we see we don't have a hypervisor in here anymore because this is a physical server, but it is using some storage on the NetApp appliance here. And we see that the write latency is very high on here. So now we have a storage problem versus a hypervisor problem. And you can drill down into a NetApp app if I had that installed on here and be able to see that information as well. So you're not stuck with this. This is an example of what you can do. You can use this environment today if you wanted to. But also the other thing that I wanted to point out is whenever we talk about apps, so you saw what we did at the beginning. We did some graphs and we saved them in the dashboard. That's basically what we're doing here. And I don't want you to get scared when I say an app is open source because you're thinking that you're going to do some programming here. Let me show you what the actual open source looks like for these apps. So I go over here to views, the BriForum app that we created earlier. This is what the app looks like. We're not talking, it's hard to see back there. Let me do
It's function up and down. Function and then your fingers.
Yeah, I was trying to do that. I guess my finger's not working. That's just going
You have to
up and
hold the
down.
function key down.
I am holding the function key down.
Oh.
It's just scrolling. Anyway, what's going on here is it's just saying, hey, create a dashboard. There's a label for it. We have a row. They put a chart on it here that says the top apps, and there's a search that got saved here, and then another row here. Hey, you're doing it good. Another row that says go do the other chart, the line chart that we created, and it saves the search in the background that we created. So when we're talking about apps or open source and free, don't say, oh, I'm going to have to go do some kind of programming now. It's just using Splunk. And so that's the dashboard, and you can see it's referencing some searches. So it saved our searches for us as well over here under searches right here. The one that we called top apps, which is somewhere around here. I have it somewhere else. But anywhere, that's what it is. So anyway, when we're saying apps are open source and free, a lot of people get, scared, open source, I'm going to have to do some programming. That's not the case. We're just using Splunk to create these visualizations and these searches for you. And so if you like this, and yes, I want to go look at the source of this, there's a little bit more involved because you see there's more to this dashboard than that first one, but you can just go see the exact same thing. You'll see the definition of this dashboard, all the searches, how they're done, and you say, I want to do something different, I want to do something similar, but a little bit change, no problem. The Splunk platform allows you to do that.
And my key takeaway from this particular dashboard, and the reason why I kind of pushed it to get created, was what I call the stack story, which is getting back when I first started working with Citrix. So it was a large company in New York, and we were doing a lot of app publishing. Actually, it was one of the first SaaS providers ever, because this was like SaaS before SaaS was even a term. And we had a lot of issues. We had 30,000 plus users logging in every month, and when a user would call in, we would be kind of chasing our tails to try to find out what link in the chain broke, right? Because this is before I was a Splunk customer. And it was like, so we'd spend so much time trying to figure out, was it the web interface? Was it the authentication? Was it the server? Was it the XenApp server that the guy was going to? Was it the storage or the physical machine that the XenApp server was sitting on? All that kind of stuff. And then it even got more complicated when they started doing virtualization, and the virtualization was on storage. So I was like, this has been kind of one of those problems that's plagued me my whole IT career, which is getting this kind of point to point, end to end. I want to see when a user calls in, I want to see everything that impacts that user in one dashboard and one screen without having to worry about going to look at like 5,000 log files. So when I first started with Splunk, this was the first thing I wanted to get done. I was like, we got to have this. we got to make this happen. Now that I got like Splunk people that knew how to do the Splunk foo on the back end to make it happen. So don't underestimate the power of being able to do this. I mean, because we've kind of just narrowed it down to just a few levels, but think about if we wanted to throw an Exchange in there, if you wanted to throw in a business continuity app, or anything that you wanted to put in this kind of stack, as I call it, you can do that as long as there's a connection point, if there's a way to correlate it to a user indirectly or directly.
Yep. So a couple more things before we break here. So that's it for demos. Unless if there's something specific, we could probably do live here as well. But the other things I wanted to point out, I got my internet connection back up here. Yeah, and so there's a free download. So if you go to Splunk.com, you can download Splunk for free. The way Splunk is licensed is, since we don't know how much, we don't know what the data looks like beforehand, we don't have any idea the number of nodes or anything like that coming in. Splunk is licensed on volume consumption in a day. And so how much data comes in a day is how Splunk is licensed. All the data, as you can see, is just text data. And so this free version is limited to 500 megs of text data coming in a day. That's great for smaller environments or even doing proof of concepts. So you can download that for free forever. There are a few features that are not on there, such as you don't get your API. So if you want to do some programming stuff against Splunk, Splunk is, again, it's a platform. There's a lot of APIs if you want to go plug into Splunk.
Yeah, for you devy people that actually do like to write code, Splunk really is a platform. We have a 5 or 6 or 7 or 8 SDKs where you can actually build a solution around Splunk without ever even touching the web interface.
Yep.
Like you can actually build your own GUI, you can build your own external analytics if you want to do some more data scientist type stuff. You could do that with Splunk.
Yep. And the other thing I wanted to point out is the what we call Splunk Base. Just splunkbase.com, or you can go a link off of splunk.com. There's a couple of things to point out here. First of all, we have Splunk Answers. We have a very active community of people doing questions and answers, and Splunk people are full-time staff to actually go and make sure these questions get answered. But also over here are apps as well. So when we start talking about apps, if there's some use case that you have, you can come over here in your search bar and type in that and kind of find if there's already an app existing for that. Again, these apps are open source, so it's like, hey, I really like this XYZ app. Type it in there, see if there's something already out there for it. If there is, then you can plug it in, kind of see how they're doing the data collection, some of the visualizations, use it as is, do your own stuff with it. Most people start with an app and they'll say, all right, I'm going to really expand on this for my environment because it's very flexible. And there's probably about 400 or so apps that are already created for you out here. A lot of them are from Splunk. A lot of them are just from individuals that want to contribute as well. So there's Splunk apps out here, and then there's individual apps out here as well. So a lot of people contribute to the Splunk community. Okay. And I think we actually do have time just to show, this is what we were talking about earlier on the architecture, and I promise this will be it. So
also along that lines, if you look at the Trifold,
yep.
There's a more detailed version of that here.
Right. So you start out with Splunk. You install Splunk on an operating system that we already went over that. It can be multiple types of platforms, and then you have these the Splunk forwarders, which are optional because you can tell Splunk to reach out and go grab something remotely, bring it into Splunk. What we've been talking about mostly are these forwarders where we install that on something and tell it to go collect information and send it to Splunk. So this is like a very small architecture for Splunk. You can't get away with just that one piece right there. Then we scale out to say, like, all right, well, we have this search, kind of what we call a search head. So a Splunk platform could be broken up into multiple pieces. And so we have this search head, and we have lots of indexers. Indexers are where your data lives. So when we index all that data, they live on an indexer, right? And then you have your search head that will send its searches to the indexers. We use something called MapReduce to make these very, very fast searches. MapReduce was invented by Google, where I think of it as a multi-threaded process where you have a parent process and you have threads that go off and do stuff, and their work is returned. They go back to the parent process. That's what MapReduce is doing. So your search will get split up into multiple indexes, and they'll return their pieces as it comes in, makes it very fast. And then you have all your forwarders down here going in.
And forwarders can have more than one index.
Yes.
So you can either send the data twice, or you could tell it to load balance. So you could give a forwarder like 10 indexers, and then it will kind of, in between it and the indexer, they'll determine what the best load is. So that if you lose an indexer halfway through the day, it'll automatically swap over to another indexer.
Yeah. And there's HA built into all of this, so you can lose an indexer. You can think of it as like a RAID array. So if you lose one, the others can assemble all the pieces for you. So there's HA built into this as well. And I already mentioned the MapReduce. This is a definition of MapReduce, where it came from. It came from Google. And then finally, this is would be a very multinational company where you have a headquarters right here.
I know y'all can't see it because I can't see it, and I'm standing right here.
Yeah, and this is like a geo that's in New York, a geo is in Tokyo, a geo in London, and each one of these geos has that architecture. But you can search over your entire infrastructure, and there's granular controls built in as well with Splunk, so you can say who can see what. So you can, if somebody's up there at the very top that wants to search your entire global organization, they can, or you can say only.
And you can use Active Directory authentication.
Yep.
There's a lot of stuff that can be done there.
Sure, absolutely. And that is it. Questions?
Yep. Questions? Yes.
So those indexers are really not a cluster in the traditional sense, right?
They can be. So with Splunk 5, we introduced the concept of Splunk clusters, and we're extending that in the next version. But they can or can't. They don't necessarily have to be.
Why would you want to? Why do you guys?
So when he said the HA was built in, you would have to have the clusters for the HA to work. Yeah. There's a little bit of more. I mean, like these can get going. Yeah.
Yep.
Any other questions?
Mobile apps? Any mobile app front end to do that?
So all of this is HTML5 based. So yeah, it just works.
For viewing your data, it just
For
works.
viewing the data at least.
There are some,
Yep.
and there are some things in works for
Collecting
gathering data from actual devices as well as for your MAM, MDM solutions.
So maybe this is a good class to ask a question because I've been kind of debating on whether I want to pursue this or not. So y'all all know AtWorks, the Citrix stuff, right? So we're thinking about having an SDK for AtWorks. So if you write an AtWorks app, we can data collect from that. And the way that you would do it is with the AtWorks app, you would just have to add the Splunk SDK. And then whenever you wanted to write to Splunk, you could just do, myapp.write_Splunk, and then like pass it the text that you want to send. So I don't know. I mean, sounds cool, but I don't want to invest a lot of resources on something just because it's cool.
Yeah. So basically, the question is like, is it worth getting information off of a mobile device to be able to visualize that in Splunk, like the device itself?
Like we can get some stuff from an MDM, so we
Right.
don't necessarily have. So it's kind of one of those things. We know, I mean, we're not idiots, so we know mobility is important. And we know there's a lot of needs in mobility. So if any of you guys are like mobility, like that's your thing, some people will, like if Chris Fleck was here, we could have hours of conversation on this. Stop by the booth, let me know your thoughts, because I'm really kind of making that determination now, how much resources we want to commit and what the return on investment, I guess, would be. Any other questions? All right. I think we're like giving away a TV or something. So
Yeah.
I think they're supposed to announce it soon. I think you have to go to the booth and get scanned. So I don't know if being here is enough, but
Good luck. Thank you.